Good day, everyone, especially to you, ma'am. Good day. So, before we start discussing our topic report, I would like to introduce ourselves. I am Kiana Villar, together with my group mates, Siti Nurjana Ambil, Irish Balisco, Christine Jane Minyoza, Abduliza Makapundag, Ella Pendig, Clarice Uga, Avenger Uto, and Nasruddin Ebus. We are the group 4, and our topic is all about the aromatic rings. What is aromatic rings? Aromatic rings is a special types of ring-shaped molecules that are very stable because of how their electrons are arranged. When we say aromatic rings, it is the type of organic compound that's got a special kind of ring structure. They are called aromatic because they often had a nice smell but not always. Aromatic rings are typically made up of carbon atoms arranged in a planar, ring-like shape. They are usually pretty stable and have some unique properties that make it super useful in chemistry and in industry. So, the features of aromatic rings is that based in Huckel's rule is ring-shaped, flat structure, fully conjugated, and follow the 4n plus 2 rules. So this will be discussed later on. Why aromatic rings are important? This is the question now. Why is it so important? Well, when it was just a chemical substance or what we call a compound. Aromatic rings may just a compound or chemical compound that can't be seen in our naked eyes, but it has a very useful. It has a good impact in our daily lives. Like for example, the things that we commonly use in like in our chores, like washing our clothes, like when we are taking our medicines when we are sick, and a fuel when we are driving our car or any vehicles. So that is the reason why aromatic rings are important, especially to our daily lives. So it is very chemically stable and then found in many drugs, dyes, plastics, amino acids, and many biological structures. So, aromatic rings are commonly found in pharmaceuticals and energy. And the word energy is what I just said, which are found in fossil fuels, and it can be used as fuels or feedstocks. And pharmaceuticals, we all know that it is the medicines. It is the medicines that we take when we are sick. So, aromatic rings are found in there too. So now, let us proceed to benzene. We all know that benzene is the most common or the most popular example in aromatic rings because it is quite simple quite simple structure rather than the other uh, samples. So benzene is a is an aromatic hydrocarbon with the chemical formula of C6H6. It is a ring-shaped molecule made of 6 carbon atoms with alternating double bonds. It is the simplest. Benzene is the simplest and most well-known example of aromatic hydrocarbon. Now, let us proceed to its structure. Molecular formula C6H6. It is composed of 6 carbon atoms and 6 hydrogen atoms. The C6 are the carbon atoms, which is 6, and H6 is the hydrogen atoms. So that is the reason why it is a hydrogen carbon, because of its molecular formula. The structure. The structure is 6 carbon atoms are joined in a planar hexagonal ring with 1 hydrogen atom attached to each carbon. Based on the image that we are seeing right now in this presentation, this is the structure of benzene, a hexagonal shape type, and it has this um, signs or the names, the signs or the symbols of carbons and hydrogen. The aromaticity. The stability comes from the localized pi electrons across the entire ring. Instead of fixed alternating single and double bonds, the historical Kekule structure, the 6 electrons are shaped equally by all 6 atom carbons. It is often presented by a circle inside the hexagon. The physical appearance. It is a colorless, highly flammable liquid with a sweet aromatic odor. So now let us proceed to the uses of benzene. Based in industrial use, it is known for its industrial use, since it is a chemical compound, and those uh, things that we always use in our daily lives are plastics, number one, and the plastics, the resins, the synthetic fibers, the rubbers, dyes, detergents, and medicines. And in agriculture, benzene is common known as pesticides. No, it is the uh, number one ingredient in creating a pesticide to kill pests in the farmland. The natural uses, or let us say the natural sources. Benzene is a natural component of petroleum and is also produced by volcanoes and forest fires. That is the reason why benzene is one of the organic compound in organic compound, is because this compound is commonly found in nature, in volcanoes and forest fires. Common exposures. It can be found in vehicle exhaust, industrial emissions, and significantly in tobacco smoke and gasoline. Even though benzene is always using by all people, like by us, it has negative impact in our body too. Because even though benzene is a very useful a very useful compound, it benzene is a compound or a chemical. It is still a chemical, and it is still had a bad impacts in our body too. So benzene is highly toxic and is classified as a known human carcinogen or cancer causing agent by many health organizations. For long-term exposures, 4 months 4 months and years, 4 months or years, it can harm the blood-forming tissues, particularly the bone marrow, leading to anemia, and damaging the immune system, and increase the risk of developing leukemia. And the short-term exposures is when breathing in high levels can cause neurological effects like drowsiness, dizziness, headaches, tremors, and in extreme cases, unconsciousness or death. So that is all.
Good day, everyone. I am Irish P. Balisco. So, my topic is all about toluene. What is toluene? So, toluene ay isang organic compound na clear na liquid and may matapang na amoy na parang paint thinner. So, its chemical formula is C7H8. So, ang chemical formula niya ay C7 and H8. So, it's also called methylbenzene because it is basically a benzene ring with one CH3 methyl group attached. So, next is the properties of toluene. So, first is flammable or madaling magliyab o mag-apoy. It evaporates quickly or mabilis mag-evaporate or mabilis mawala sa air kapag naiwan sa open air. It dissolves many substances which is why it is used as solvent. So, madaling mag-dissolve ng substances kaya ginagamit bilang solvent sa maraming process. So, next is why is it important or bakit mahalaga ang toluene? Is used to make other chemicals like TNT, benzoic acid, benzaldehyde, and polymers. So, bakit importante, so ginagamit ang toluene para gumawa ng ibang chemicals like TNT, benzoic acid, benzaldehyde, polymers, or panggawa ng plastic o synthetic material. So madalas din itong gamitin sa mga laboratories bilang non-polar solvent. Next is safety. So breathing too much toluene can cause dizziness, headaches, or confusion. High exposure is harmful so it must be used with proper ventilation. So kapag masyadong maraming na-inhale na toluene, pwedeng magdulot ng pagkahilo, sakit ng ulo or headache, pagkalito. And delikado ang mataas na exposure kaya kailangan laging may proper ventilations kapag ginagamit ang toluene. So that's all. Thank you.
Good day, ma'am. I am Siti Narjana Emambil and I will be tackling about naphthalene. So, naphthalene. Naphthalene is an organic compound with the chemical formula C10H8. It is the simplest of the polycyclic aromatic hydrocarbons. So, naphthalene is a white crystalline solid that is volatile and has a strong distinctive odor commonly associated with mothballs. So, ang naphthalene ay isang organic compound na pinakasimpleng halimbawa ng polycyclic aromatic hydrocarbons. Sa simpleng salita, ito yung puti na crystalline na solid na may matapang na amoy. So, ano nga ba ang structure and properties of naphthalene? So, structure. Its molecule consists of two fused benzene ring, making it a planar flat structure. So, binubuo ito ng dalawang benzene string fused together that contains carbon and hydrogen. So, ano nga ba ang aromaticity nito? So, it is an aromatic compound, though it is carbon-carbon bonds are not all the same length, unlike benzene. So, although carbon-carbon siya, hindi siya same length, unlike sa benzene. So, saan nga ba nag-occurrence ang isang naphthalene? It is found naturally in crude oil and coal tar and is also produced when organic material burns. So, nahanap ito siya sa krodo ng oil and yung kapag may nasusunog na organic materials, katulad ng lupa, and so on. So, natutunaw lang ang naphthalene sa organic solvents, which is alcohol and ethanol. So, uses and health concerns of naphthalene. Uses, moth repellent. So, ano nga ba ang moth repellent? This famous used in mothballs. Ito yung pumapatay ng mga insekto like moths and chemical manufacturing. Ito naman is yung mga raw materials for producing chemicals, especially yung phthalic hydride and naphthalene sulfonates. So, ang mga health concerns ng naphthalene. First is toxicity. Once, once na ma-expose ka dito, ay magkakaroon ka ng nausea, vomiting, headache, and confusion. Second is magkakaroon ka ng hemolytic anemia, which is kapag masyado kang na-expose dito in high level, can cause abnormal breakdown of red blood cells and a condition called hemolytic anemia. So, thank you po, ma'am.
So, hi everyone, assalamualaikum, and good morning ma'am, and good morning to all of you. First of all, I am Avenger Uto, and my topic ho is all about the fused rings. So, let's start. What is fused rings? So, a fused rings, it's a structure made of two or more rings that share two adjacent atoms and the bond between them. In the other words, the rings are directly attached to each other by the sharing aside. So, kapag sinabi nating fused ring naman, isa siyang one or more two rings sa isang molecule na kung saan tumutukoy ito sa uri ng pagkadugtong ng dalawang singsing sa isang polycyclic compound. So, the more na nagbaband sila or nagbabago or nag-change ang kanilang physical at chemical properties. So, yun yung ibig sabihin or definition ng fused rings. So, let's proceed to the example of the fused rings, which is the number one, the decalins. So, kapag sinabi naman decalins is they are the saturated hydrocarbons forms from two fused 6-membered rings. So, kapag sinabi nating decalins naman is isa siyang fused rings compound na binubuo ng dalawang cyclohexane rings na magkadikit sila at nagbabahagi or nag-share din ng isang gilid or 2 atom plus 1 bond. So, yun yung ibig sabihin ng decalins. So, makikita natin sa picture kung makikita natin sa picture yung dalawang cyclohexane rings na magkadikit, di ba? So, nag-share sila ng dalawang gilid or nag-share sila ng nagbabahagi sila ng dalawang atom plus 1 bond. So, of course, meron tayong tinatawag na cis-decalin and trans-decalin. So, ito yung two type of decalin. So, cis-decalin is they are saturated hydrocarbons forms from two fused 6-member rings. So, ang decalins naman is dalawang cyclohexane ring ay nakaharap sa iisa or like parang same direction siya. So, mas flexible kumpara doon kay transdecalin. So, pwede siyang magkaroon ng flipping tulad ng cyclohexane. So, yun yung ibig sabihin ng cis-decalin. So, next is the transdecalin. So, is one of the two stereoisomers of decalins, which is the fused ring system made of two cyclohexane ring sharing one side. So, sa transdecalin naman is ang mga rings ay nakaturo sa magkabaliktad ng direction. So, unlike kay cis-decalin na same direction. So, kay transdecalin naman is hindi nakapag-ring flip. So, yun yung ibig sabihin ng transdecalin. So, let's continue to the example of fused rings. Number 2 is steroids. So, a class of lipids that have a characteristic structure of 3 6-membered rings and a 1 5-member rings fused together. So, kapag sinabi naman natin na steroid is isa siyang organic compound na may 4 na fused rings or may 3 cyclohexane rings at isang cyclopentane rings. So, sa madaling salita is mahalagang klaseng sa madaling salita, ang steroid is fused rings na may mahalagang biological compound. So, yun yung meaning ng steroid. So, the number 3 example of the fused ring is yung indol. So, benzene fused to pyrrole or pyrrole. So, ito naman parang ano siya, parang mahalaga sa indol naman is isa siyang mahalagang klaseng heterozygotic aromatic compound na binubuo rin ng fused rings. So, di ba, for example, may isang benzene rings na may 6-membered ring or isa siyang pyrrole ring na may 5-member ring na may nitrogen atom. So, yun yung indol. So, type of ring fusions is number 1 is orthofuse. Pag sinabi nating orthofuse is ring share the two adjacent atoms or most common is often simple called fuse. So, ortho is a fused rings na kung saan may dalawang aromatic o non-aromatic strings na nag-share sa gilid dito. So, parang kapag may dalawang benzene ring o iba pang cyclic compound at naka-fuse sila o sa magkatabing carbon atom, so tinatawag itong orthofuse. So the next one is the bridged rings. So rings shares more than 2 atoms through a bridge. So dito naman kapag sinabi nating bridge rings is ito na yung when we say braid rings is may dalawang rings or more rings pero hindi sa gilid. Ibig sabihin hindi lang basta magdadikit ang dalawang ring kundi may another atoms na nagtatali sa kanila. So yun yung braid rings. So the last one is the spiral rings. So rings share only one atom, also not fused but often taught alongside. So ang spider rings is may dalawang rings na nagkakabit sa isang atom lamang. So, ang atom na iyon is tinatawag na spiroatom. So, meaning hindi sila nagbabahagi ng buong gilid gaya ng unlike sa fused ring, kundi isang punto lamang yun. So, yun yung ibig sabihin ng spiral rings. So, yun lang po. Maraming salamat. My name is Avenger Uto.
So, good day everyone. Good day, ma'am. So, ang i-discuss ko ngayon is ang heteroaromatic ring. So, ano nga ba itong heteroaromatic ring? So, basically, ang aromatic rings ay ang mga bilog na molecules na very stable at may special na electrons na tinatawag na delocalized electrons. Pero kapag ang heteroaromatic, hindi lang ang carbon ang laman ng ring, may kasamang ibang atoms, usually nitrogen, oxygens, and sulfur. Ang tawag sa ibang atom na ito is heteroatom. Kahit na may ibang atoms, aromatic pa rin siya dahil flat or planar, stable at may denuclearized electron. Mahalaga or importante itong heteroaromatic ring. First is sa medicine. Maraming gamot ang may ganitong rings sa structure nila. Halimbawa, omeprazole. Omeprazole ay ginagamit sa ulcer o acid reflux. Ang heteroaromatic ring dito ay nagbibigay sa gamot ng stability at tumutulong para gumana siya ng maayos sa ating mga katawan. Pangalawa is sa perfume at natural compounds. May mga chemicals na galing sa heteroaromatic rings na ginagamit sa pabango at iba pang natural product. So, pangatlo is biological molecules. Makikita sila sa DNA at amino acid, meaning part sila ng katawan natin at mahalaga para gumana ng maayos ang ating mga cells. In short, ang heteroaromatic ring ay important sa medicine, fragrance, and biology. Next naman na pag-uusapan natin is yung 5-membered heteroaromatic ring, meaning may 5 sides ang ring. So first is pyrrole. May nitrogen sa loob. Ginagamit siya sa natural pigment at chemical reaction. Next is si furan. May oxygen. Medyo mas reactive siya pero useful sa flavors at natural compound. Next is thiophene. May sulfur, mas stable siya at ginagamit sa pharmaceutical chemicals. So, dito naman tayo sa 6-member heteroaromatic ring. Yung 6-member heteroaromatic ring ay parang benzene na may isang heteroatom. So, ito si pyridine. Pyridine like benzene ring na may isang nitrogen. Stable siya at ginagamit sa paggawa ng medicines, vitamins, at iba pang chemical reaction. So, may iba pa tayong important heteroaromatic ring. Ito si imidazole na may dalawang nitrogen atoms. Part ito ng histidine na isang amino acid sa katawan. Ginagamit sa medicine at biological reaction. So, next is indole. Pinagsamang benzene plus pyrrole ring. Makikita ito sa serotonin chemical na responsible sa happiness natin. So, in summary, heteroaromatic ring ay aromatic ring na may heteroatom.
Good day, everyone. My name is Clarice Tuoga and my topic is all about the aromaticity. So, ito siya. So, ano ba yung aromaticity? So, it is a special property of some ring-shaped molecules that makes them extra stable. Not all rings are aromatic, only those that follow certain rules. Aromaticity is the unusual stability shown by certain cyclic ring compounds because of the continuous sharing of electrons in the ring. So, aromaticity is, ito lang yung ang katangian na ring-shaped molecules na that gives an extra na stability or tibay. So, hindi lahat ng may ring ay aromatic. So, need pa nilang sundin yung ilang tamang kondisyon tulad ng tuloy-tuloy na pag-delocalize electrons at tamang bilang ng R or electrons. So, ang aromaticity is nangyayari kapag ang isang cyclic compound ay may tuloy-tuloy na pag-share ng electrons, or ito yung walang putol na conjugation, which is like hindi putol-putol yung mga kabit nila. So, electrons is malayang gumagalaw sa buong ring. So, ginagawa nitong mas matibay at mas stable ang molecule kaysa sa normal na structure. So, dahil ang electrons ay umiikot o kumakalat sa loob ng ring. So, nabubuo ang tinatawag na resonance system. So, parang may shared energy na nagpapababa ng reactivity at nagpapataas ng stability. So, proceed naman tayo sa characteristics of an aromatic ring. Paano siya nagiging aromaticity? So, number 1 is, kailangan ang ring must be cyclic. So, ito siya. Kailangan cyclic siya. The molecule should form a ring. So, kailangan naka-ring o nakabilog ang structure ng ring. So, example nito, this is the benzene. We have 6 carbon and 6 hydrogen. So, ito siya. Number 2 is must be planar or di kaya flat. Yung aromatic ring is flat. Yung nakikita nyo yung sa baba, guhit. So, kailangan naka-flat siya. So, dahil dyan, the ring should be flat so electrons can move freely around it. So, dahil dito, ma-overlap na p orbitals ay may mas magiging stable siya. So, number 3 is must have continuous conjugation. So, dapat magkadikit-dikit yan sila, hindi hiwalay. So, conjugated like may alternate double bonds. So, there should be alternating single and double bonds or lone pairs that allow electrons to be delocalized around the ring. So, dapat lahat ng atom sa ring ay may p orbital na nag-overlap. So, pwedeng may alternating double bonds or something na equivalent or resonance. So, number 4 is must follow the Huckel's rule. So, we have the 4n plus 2 electrons. So, the ring must have 4n plus 2 electrons wherein is any whole number or like 0, 1, 2, 3, so on. So, example nito is n is equal to 1 which is 6 electrons, then aromatic. Then n2, 10 are, the meaning nito is that is electrons which is aromatic. So, kailangan number ng electrons is nakasunod sa formula. Like, kanungan na nga, 4 plus 2. Like, example sa benzene is, benzene has 6 electrons. So, pasok siya sa aromatic ring, which is 4 times 1 plus 2 is equal to 6 electrons. So, yun lang po. Thank you.
Good morning, ma'am. My name is Christine Jane Menyosa. Today, I will be discussing my topic, which is the planarity. What is planarity? In chemistry, planarity refers to the extent to which the atoms in a molecule lie in the same geometric plane. A molecule or part of a molecule is a planar if all its atoms can be placed on a single flat surface without distortion. Planarity also influences stability, reactivity, aromaticity, conjugation, and molecular reaction. So, ang planarity daw ay isa siyang katangian ng isang molecules na lahat ng atoms nito ay nasa iisang eroplano lang. Ibig sabihin, for example, kung ipa-flat mo ang isang molecule, makikita mo ito na hindi tumataas o lumulubog sa ibang direction. Kasi lahat ng atoms ay parang nakalagay lang sa isang papel. Ganun. So, also, ang planarity ay ang pagiging patag sa isang molecule kung saan lahat ng atoms ay nakapwesto lang sa isang parehong eroplano. Next is why planarity matters. Number 1, electron delocalization and resonance. Many planar molecules allow electrons from double bonds or lone pairs to delocalize across the structure. For example, benzene is planar, which its 6 electrons to be evenly delocalized, creating extra stability or aromaticity. Kay non-planar naman, molecules often prevent effective overlap or p orbitals, reducing resonance stabilization. Number two is conjugation. Conjugation occurs when alternating single and double bonds allow electrons to spread across multiple atoms. So for effective conjugation, the atoms involved must be complanar. Also, this affects B's absorption, color or color of compounds, and reactivity, electrophilic and nucleophilic reactions. So number two naman is stereochemistry and reactivity. Planarity can influence the approach and reactants in chemical reactions. For example, in aromatic substitution, electrophiles attack a flat benzene ring, not a twisted one. Non-planar molecules naman may have the steric hindrance that reduce reaction rates or changes reactions pathways. So number four is hydrogen bonding and physical properties. Planar molecules can pack more efficiently in solids due to their flat shape. For example, si planar amides can form uh, stronger hydrogen bonds because the lone pair on nitrogen and the carbonyl bond are in the same plane. This affects nakaka-affect siya by melting point, boiling point, and solubility. Next is number five, biological significance. Many biological molecules like DNA bases, aromatic amino acids are planar. Sila yung mga planars na nakakuha sa mga biological molecules natin, yung mga DNA bases, aromatic amino acids, sila ay planar. Planarity allows stacking interaction which stabilize structures like DNA, double helix, or protein folds. Yun yung mga biological significance. Next here, I have some example concept which delocalization in benzene, flat structure, planar benzene. So, here, all 6 carbons lie in the same plane. Each carbon has a p orbital perpendicular to the plane. These p orbitals overlap the sideways across the ring, forming decollized system. Decollization stabilizes the molecular aromaticity. Yun siya, yun ang example. Next is ang non-planar scenario naman. Sa non-planar scenario, if the ring were twisted, p orbitals no longer align properly. Overlaps of p orbitals is disrupted. Si decollization is lost, molecule becomes less stable. Nagiging less stable yung decollization pag nalolos yung si molecule nalolos, molecule becomes less stable or parang nagiging less stable yung molecule pag nawawala si decollization. Yun lang, thank you.
Good day everyone and ma'am. I am Ella Pendig. Ang i-discuss ko po is about delocalization. Meaning, delocalization is the spreading of electrons over multiple atoms or bonds. Electrons are not confined to a single bond or atoms. Meaning, ang delocalization means ang electrons hindi lang naka-focus sa isang band. Nag-share sila or nag-spread sila across multiple atoms. Kaya mas stable ang molecule. Key idea. Delocalized electrons move freely within a molecule. This increases molecule stability, often shown using resonance structure. Yung key idea ng delocalization is that yung electrons sa molecule hindi lang nakastay sa isang band, kundi free silang gumagalaw sa iba't ibang part of molecule. Bakit nangyayari ang delocalization? Usually, nangyayari ito sa molecules na may double bond, resonance structure, aromatic. Example is benzene. Sa benzene ring, yung electrons nag-share ng buong ring. Hindi lang sa isang band, kaya stable ang benzene at may unique properties dahil sa movement ng electron sa circle. Another example is nitrate ion. Sa nitrate naman, yung negative charge hindi lang nakafocus sa isang oxygen. Nag-spread siya sa lahat ng oxygen atoms, kaya mas stable yung ion. Importance of delocalization. Increase molecular stability, lowers energy of the molecule, explain properties such as color and creativity. Ang importante ng delocalization kasi mas stable ang molecule kapag nag-spread out ang electrons. Mas mababa ang energy ng molecule, meaning hindi siya madaling masira. Thank you!
Good morning, ma'am. My name is Ibus Nasruddin. So, aromatic rings ito yung pangunahing katangian. Aromatic rings So, ang aromatic rings hal is benzodiazepines ay kilala sa sobrang stable. Ang stability naman ito ay mula sa aromatic C na may delocalization ng electrons sa ring. So, ibig sabihin, malayang gumalaw ang electron sa buong sining. So, electron delocalization creates stable electron front. So, sunod na nila ang Haeckel rules na nagsasabi ang isang compound ay aromatic kung mayroon itong 4n plus 2. And electron hal is number 2.6 and 10.14 electron. So, why aromatic rings are stable? So, dito naman sa aromatic rings is bakit stable daw ang aromatic rings? Dahil daw sa conjugated system sila. Nagkakasunod-sunod ang double bonds, kaya pwedeng mag-move ang electron sa buong ring. Ang cyclic decalization naman is electron ay nagpapababa ng energy ng molecule. Kaya nagiging mas stable ito. Dahil ayaw mawala ng stability nila, iniiwasan nila ang additional reactions na puputol sa aromatic C. So, mas prepare nila ang substitution ng reaction para mapanatili ang ring at hindi masira ang aromatic system. Thank you po, ma'am.